Welcome back. This is the last lesson in our pre-AP chemistry math homework. So the last lesson we're going to do is on density. Density is defined as the mass of a substance per volume. Density is a physical property. For instance, a ping pong ball and a golf ball occupy similar volumes, but the golf ball is heavier. Therefore, the golf ball, we call it denser than the ping pong ball. It's more mass per the same volume. If a substance is denser than water, it will sink in water. And if water is denser, the substance will float. Metals have specific densities that can help in identifying them. The equation for density, which I've talked about in previous lessons, is density equals mass divided by volume. So let's look at this sample problem. A 10.0 centimeters cubed sample of copper has a mass of 89.6 grams. What is its density? So density is already isolated in this equation. So we just plug in mass, 89.6 grams, divided by 10.0 centimeters cubed. Okay. A lot of people, when they solve a problem, I was going to say one thing. I'm going to say one more thing. When they're written on top of each other, this is division. Most people know that. 89.6. Let me make sure I enter that correctly. Divided by 10. By the way, if you divide by 10, you just move the decimal. So I don't know why I put that in there, but I guess I'm talking to you and I wasn't really thinking. So it's 8.96. The question that people have is, well, Ms. Fine, what are the units? And the units are right here. If you keep your units in the equation, which I tend to do, I always know what the units are. I don't have to ask someone. It's not like coming down from heaven what the units are. They're right here. The units are grams per centimeters cubed. Now, I want you to solve this problem. They're asking for something different than density. They want to know mass. So you're going to have to manipulate the equation. Pause the video here and solve this problem, and then come back and I will review that with you. Welcome back. It says here ethyl alcohol has a density of 0.789 grams per milliliter. What mass of ethyl alcohol would fill up a 20 milliliter container? So this is density. We don't know the mass, right? And this is volume. So density equals mass over volume. Since we're solving for mass, we need to get mass by itself. Right now, mass is being divided by volume. So to get mass by itself, we're going to have to do the opposite of dividing by volume, which is multiplying by volume. And what we do to one side of the equation, we do to the other. So our equation becomes mass equals volume times density, which is 200.0 milliliters times 0.789 grams per milliliter. The other thing that writing your units helps you do is see if you have a unit agreement. Yes, I have milliliters here and milliliters cancels out here. So I don't have to do any conversions. I just have to multiply this across. 200 times 0.789 gives me 157.8. It looks like this is 3 sig figs and this is 4 sig figs. Remember, we don't give an answer in more sig figs than our least precise measurement. So we're going to look for 3 sig figs in our answer. So this is going to become, we're going to look at so I have 157.8 and I want 3 sig figs. So I look at those first 3 significant digits and ask, does the 8 round up to 7? It indeed does. And we have 158. Again, a question about units. Units are not ordained from above. Franklin, no. And then a question about units. Units are not ordained from above. Milliliters cancels out. We are left with grams. Here's another problem for you to do. Solve this problem. We'll pause the video, solve this problem, and then come back and we'll do it together. If you're back, that means that you have solved this problem. So let's do it together. What volume? So we need to know volume. What volume of gold metal would weigh 25 grams? That's mass. Gold has a density of 19.32 grams per milliliter. This is 3 sig figs. This is 4. So my answer is going to be in 3 sig figs. Okay. But I want volume. So the equation is density equals mass over volume. Oh no, how do I solve for a variable in the denominator? Again, we're just gonna flip it. So in other words, 1 over d equals v over m. I want to solve for volume. Volume right now is being divided by mass. To get rid of the mass, I'm going to do the opposite. I'm going to multiply by mass. And what I do to one side, I do to the other. So volume is equal to mass divided by density, which is 25.0 grams divided by 19.32 grams per milliliter. 25 divided by 19.32 gives me a long number, I'll put it up here, 1.29399. I don't even know all these numbers. I wouldn't even know naturally where to cut this off, but sig figs are telling me where to cut it off. Remember, we want 3 sig figs. So I look at the first 3 significant digits and I go only one digit past and ask, does the 3 round up a 9? Well, a 3 never rounds up a 9, so it becomes 1.29. What about units? Grams cancels out. Milliliters is in the denominator of the denominator, which makes it in the numerator. So it's 1.29 milliliters. Let me just prove that to you. This is, we said that the grams cancel out. So we've got let me use a pen, 1.29. So it's 1 over milliliters. Milliliters is in the denominator of the denominator. How do I know that's in the numerator? Well, to get it out of the denominator, I could multiply the denominator by milliliters. But I can't just do that because I need to multiply by 1. If I multiply by 1, which is 1 milliliter over 1 milliliter, the milliliters in the denominator cancel out. And notice I'm left with milliliters in the numerator. So if your unit is in the denominator of the denominator, it's the same thing as in the numerator. So it's 1.29 milliliters. And finally, our last lesson for this packet, determining volume by water displacement. An accurate method of determining the volume of a substance, especially if it's irregularly shaped, is to measure the volume displaced when the substance is submerged in water. Now, there's a well-known story tale. I don't know if it's true, but Archimedes worked for the king. The king had ordered his crown perhaps rejeweled or made or something like that. And when he got the crown back from the jeweler, he wasn't sure if it was real gold. And he had asked Archimedes to determine whether it was really made of gold. And Archimedes did it. Archimedes thought and thought and thought, and he couldn't figure out how to do it. He didn't know he didn't know. And of course, one morning, afternoon, evening, I don't know how the story goes. He goes, takes off his clothes, submerges himself in the bath, and he realizes that the water rises by the amount of volume that his body takes up. And so he figured he could figure out the density of the crown and see if it is indeed gold by submerging the crown. He knew the mass of the crown. He could weigh that, divide by the volume of water displaced, and he would know whether it's made of real gold. And of course, this discovery was so amazing. He shouted, "Eureka!" He jumped up and ran through the city streets naked, screaming, "Eureka!" So that's how the story goes. I'm sure that there's more to it if it's even true. But water displacement is a method that's here to stay. So if we needed to find the volume of, let's say, this rock, it's not a gold crown. By the way, the crown ended up not being real gold, and I'm sure that the jeweler was probably had some due punishment due him in those days. I can only imagine what it was, but maybe he got submerged in water himself. But don't fool a king when the king has a smart scientist by his side. Or don't fool the king, period. To find the volume of the rock below, it is submerged in a known volume of water. So we have 150 milliliters of water here, okay? 150 milliliters. That's the volume before the rock is added. The increase in volume after the rock is submerged is equal to the volume of the rock. So when we look at the combined volume of the rock and the water, if I look here, 150, like what does each line represent? 150, 160, 170, 180, 195. So each line represents 5 milliliters. So it's 155, 160, 165, 170, 175, 180. So this is 180 milliliters. The combined volume of the rock and the water is 180 milliliters. So the density, let me just put here, this is 150 milliliters. The difference between the water's volume before and after the rock was submerged is equal to the volume of the rock, which in this case is 180 minus 150, which is 30 milliliters. So here's one sample problem I have for you. I want you to do it yourself. Pause the video, solve this problem. And when you're finished, come back and we'll go over it together. Welcome back. So let's solve this problem. We have 28.5 grams of iron, that's mass, is added to a graduated cylinder that's already containing 45.50 milliliters of water. So this is our cylinder. I'm never really good with my pictures. Let's say this is 45.50 milliliters of water, right? I then add iron. This is the before and after picture of my cylinder. Okay, so I add iron. I don't, is iron, it's not really red, it's probably brown. I don't really have a lot of choices here. I'm gonna do red. I add iron. Here's my piece of iron, right? Let's fill it in. The water volume goes way up, okay? It's now at 49.10. They want us to calculate the density of iron. So again, density is mass divided by volume. We know that the mass is 28.5 grams. By the way, that's 3 sig figs, right? And this is 4 sig figs. You divide that by the volume. The volume here is not the volume of the water, it's the volume of the iron. And the way we get the volume of iron is we take the volume before and after it is submerged in water. So it's 49.10 milliliters minus 45.50 milliliters. I get 3.60 milliliters, remember, because, or 3.60, because we want our answer to have the same number of placeholders as our least precise measurement, and they're both to the 100th place. So we're going to divide that by 3.60 milliliters, which is, so they're both 3 sig figs. 28.5 divided by 3.60 is a density of 7.9. I'm going to write this whole, no, I'm not going to write all the sixes, but again, just to show you how sig figs work, how you round. Since I know it's in 3 sig figs, I look at the first 3 digits and I ask myself, does the next digit, only the next one, round up at the 1? It does. So this becomes 7.92. And don't, I just inverted that a little. There we go, 7.92. And don't ask me what the units are. They're written right there. The units are grams per milliliter. So this is the end of our packet, our pre-unit, our pre-AP chemistry unit on chemistry math. I've uploaded some practice problems if you want to get more practice in density. And now we're moving on to the first unit of AP chemistry, which is atomic structure. Take care.